All right, this is our second video on our first day of probability in Honors Algebra 2. And now what we're going to be doing is running a simulation using a random number generator on our graphing calculators. There's other ways to do this. You can use online random number generators. Some textbooks have lists of random numbers in the back of them that you can use. Let me just show you why you would want to do something like this. Using a random number generator helps you to simulate certain events like rolling a die or tossing a coin, for example. So let me just show you how this works. The first thing we need to do is what's called seeding your graphing calculator. The easiest way to explain this is all of our graphing calculators come to us with lists of random numbers on them, like hundreds of thousands or millions of numbers that your graph calculator will select at random. Unfortunately, they all start at the same spot in this list. So if we were all to just generate a random number to begin with a calculator right out of the package, they'd all be the same exact number. So that's not very random. So we need to seed it so it starts somewhere different than the person sitting next to us. So here's how you do this. You pick some random 2, 3, 4-digit number. Doesn't really matter. I'm just going to pick the number 208 because that's my room number. You have to pick something different. So maybe the last 4 numbers of your cell phone number or something to that effect, your address, something, just some random number that is different than hopefully the people that are around you. So this is somewhat random. So what we're going to do here is tell the graph calculator to store this as the starting spot in the random number list. So what we want to do is hit store. Okay, and remember the last button I hit is red, so here it is right here. And then it just says, what do you want to make this 208 be? Well, we want to store it as our first random number. So we're going to go to math and this probability spot right here. We're going to be using this quite a bit today. We're just going to tell it to be the first random number. So we're going to hit number 1 right there. This is what we want. Okay, so whatever your random number is, don't have 208 there, have something different, and then store, and then rand, and then we're just going to hit enter. And it doesn't look like it really does anything, but now it's got our calculator starting at some spot in the number sequence. So here's how this works. Clear this off here. Oops. All right. So if you take a look at, actually, let me give you a quick example of just generating a random number. So what I'm going to do is go back to that. Actually, we'll go this way a little bit faster. This if I miss it, this probability menu, and we're gonna be using this rand int quite a bit today. So number 5. Okay, so for lower and upper, what I'm going to do to start with is I'm going to show you how I can use this to roll a die. So the smallest number on a die is 1, and the largest number on the die is 6. Now, if I just want to roll 1 die at a time, I would just put a 1 here. Maybe I want to roll 2 die and look at what the sum of those die is, or for some reason, I'm playing a game that needs 2 die. I don't have 2 dice on me, so I can pull out my graphic calculator and put a 2 right here, and that's like rolling 2 die at once. Okay, so I'm just going to put in a 1 here. I'm just going to put in a 1, and we're going to roll a die here. So the first roll of the die just happens when I hit enter right now. Okay, so the first time I rolled the die, I got a 1. Okay, I got a 1 again. Every time I hit enter, I'm rolling the die. So these are all the values that I'm getting as I roll this die. Okay, now your calculator actually, if you've played around with it, does have a program on it that actually looks like a die that's rolling, but it's really just doing this in the background. If I wanted to, oh, and by the way, if you have an old calculator, this is what you would need to type in: the lower bound, the upper bound, and then how many you want at a time. If you don't put anything there, if you just close the parentheses, it would just do one number like what we have here. Okay, if I wanted this to be 2, I'm just going to grab this. If I wanted it to be 2 die, I would just have to put a 2 there. Okay, so here's what I'm going to do now. I'm going to flip a coin. So what I'm going to do is just say my lower bound is 1, my upper bound is 2, so it's either going to give me a 1 or a 2, and I could do a 0 or a 1, I could do any two values. Um, I think 0 and 1 or 1 and 2 are the most common here, though. And I'm going to excuse me, I'm going to flip a coin by just putting a 1 right there. So every time I hit enter now, it's flipping the coin. Oops, I should have designated what they are. In my head, I was thinking this is a head and this is a tail. So that's a tail that I just got. I got a head now. I got another head. I got another head. So every time I hit enter, it's like I'm flipping a coin in the air, and this basically is what I'm getting as my head or my tail. Okay, and you should designate what a number stands for before you go. All right, so let's use this to simulate something here. This says the probability of an information desk at a library receiving calls each hour varies according to this following distribution. So in 1 hour, the probability of them getting 0 calls is 0.05 or, excuse me, 5%. And then these probabilities for each outcome, 0 through 5, are as follows. So 5 would be having 5 calls in an hour is a 5% chance, just the same as 0. So these are not evenly distributed like rolling a die or flipping a coin. So it says here, for example, the probability of getting 3 calls in a randomly selected is 0.3. So the probability of C equals 3 is 0.3. Where C, and I'll just put C where C is the number of calls. Maybe we could have just written the phrase probability of, 3 calls, and that would have meant the same thing. All right, so what we want to do is we want to use a random number simulator or generator, excuse me, to predict the number of calls received during an 8-hour shift. So we're going to go for 8 hours here. All right, so what we want to do is get our organization set up here, or our simulation set up here. So that's where it says organize your simulation here. So maybe not something necessarily we need to write down if you were doing a homework problem, but this is just an example, so we're showing you kind of your thought process. So we need to have our random numbers be or have 100 values. So we're going to go from 00 to 99. Now you need to keep them so that they have the same number of digits. So that's why I went with 0099 instead of saying 1 through 100. But this still represents 100 things. So we need our outcomes to be represented properly with the correct probability. So the probability, I'm basically just rewriting that table from up above. The probability of getting 0 calls is 5%. Of getting 1 call was 15. 2 was 25. I'm just putting this all in my own table so I can get kind of my head into what's going on here. All right, now this cumulative probability really isn't necessary for this problem, but knowing what the cumulative probability thing is a part of this lesson, so I thought I'd just stick it in here so that you get this definition. The cumulative probability is the probability of 0 to that value, okay? So our cumulative probability here in this first spot would just be 0.05. But the probability in this next spot would be the sum of those two guys, or in other words, this guy plus that guy. So this is going to be 0.2. And then I'm going to add that 0.25 and get 0.45. And then I'm going to add the 0.3 and get 0.75, the 0.2 and get 0.95, and then the 0.05, and there I am at 1 or 100%, which is what the final cumulative probability needs to be. So this isn't a bad idea to make sure that you have the correct, correct probability distribution, because it has to sum to 1. So let's assign some random numbers here. Just like I said that before, a 1 was a head and a 2 was a tail, I'm going to say that since I need 5% to be 0 calls, that I'm going to let the numbers 00 through 04 represent that outcome. So if I get any of those values, that means I got 0 calls. All right, that's actually 5 values, even though it ends with a 4. That's 5 values. And then from 05 to 19, is going to represent one call, okay, because that's actually 15 values there. And then 20 to 44. Notice how we don't have any overlap here. You can't, for example, one of the early mistakes students make is they're like, oh, 00 to 05, and then 05 to whatever. Well, what if you get a 05? Which one of those does it represent? So you can't have any overlap here. So that's why we do what we do here. Uh, 45, I need 30 things, so that would be up to 74. And then 75 through 94 would be 20 things, and then 95 through 99. So look, just like we said before, we're going to go from 00 to 99. There we are, from 0 to 0 to 99. And we've proportioned our random numbers exactly the way that our probability said they should be. So now what it's time to actually run the simulation. So what I'm going to do is I'm going to start from scratch here and go back to my random number generator. So I'm going to go over to probability, math probability, and I'm going to grab, now you want number 5, rand int. Okay, now my lower is 0, 0, and my upper is 99. And I'm going to go one value at a time. If you want, you could just put in an 8 and get all 8 hours at once. All right, but I'm just going to go one number at a time. I don't know, I like hitting enter. It makes me feel like I'm involved in the problem a little bit. So, okay, so the first random number I got represents what happened in hour number 1. I got a 90, okay? So I'm going to interpret that right away here, just so you see what's going on. When I got a 90, I look back up into my table and say, where did that 90 fit in here? Well, the 90 fits in right there. It's in that range of numbers. What that means is I received 4 calls that hour. Okay, so the first hour was there, I received 4 calls. So hopefully you see why we had to interval these numbers the way that we did. Otherwise, it wouldn't be representing it. If we would have put in the numbers 0 through 5 and just hit enter every time and said, oh, I got 0 calls, I got 3 calls, I got 5 calls, that's not correctly representing the probabilities, which are right here. That's why we had to use 00 through 99. Okay, so I'm going to hit enter just a couple more times and just write down what my outcomes are here, my random numbers that I get, and then I'm going to come back and I'm going to interpret them. So what you should be doing here, if you're doing this on your own, you're going to be getting different numbers here. That's perfect. We all want to be getting different numbers here. Okay. All right, there's my 8th hour there. Hopefully I didn't skip one. My calculator's being a little glitchy here. So you're going to have different numbers right here. What you need to do now is go ahead and find out where your numbers fit in here and what number of outcomes it represents. That's the whole idea behind this, is we're simulating this. So instead of having you and I both sit down at this, whatever it is, a library for the next 8 hours, we're going to have everyone in our class, so like 30 people, simulate doing an 8-hour shift by running this simulation. All right, so we've got this 38 would represent, that's in there, so that would represent getting 2 calls. 46, I'd get 3. 66, I'd get 3. 65, I'd get 3. Boy, I'm getting a lot of those. Well, that's because there's a 30% chance of getting 3 calls in an hour. 81, getting 4 calls. 66, I'm getting 3 calls again. And 44, I just squeaked out a 2-call hour. So, if you haven't yet, pause the video, go ahead and run your own simulation. It's kind of interesting to find out how mine compares to yours, how yours compares to the people around you. But that's what I got. Over an 8-hour period, my simulation says that I'm going to get, let's add these up here real quick. We have 9 and 6 is 15 and 7 is 22, 24. Okay, so mine says over an 8-hour period, hold on here. There we go. Just get right here. Oops. Predicted number of calls in my simulation over the 8-hour was 24 phone calls. Then I just threw kind of an average in there, just for the heck of it. Obviously, mine worked out to be a nice number, being 24 divided by 8. But you could just round yours. And I know you can't have, a decimal phone call, but we're giving an average, so that's okay. um, so hopefully we all have some different values here, so we can kind of compare. But what we would do then is look at, if we have a full class of people doing this, we're doing like 25 to 30 simulations. We'd have a pretty good idea what to expect given this probability distribution here.